So now we get to put together what we talked about in Chapter 6 about the formation of our solar system with the planets. So we're going to start out with the rocky or the terrestrial planets that formed close to the sun, where it was hot but not so hot that metals and rock would not come out of their gaseous state. So we're going to focus on the rocky or the terrestrial planets first. So what helps is to compare, the terrestrial planets obviously are Mercury, Venus, Earth, and Mars, to compare them to Earth. And what we're going to see is they have similar kind of structure with regard to the metals and rocks that made them up during the process called accretion. And so you may be already kind of familiar with the Earth. So the gray part there is the Earth's core. And actually there is an inner solid core and an outer liquid core, but we're just going to call it the core for now. And then that kind of peach colored or kind of orange colored is the mantle. Actually there's a liquid mantle and a solid mantle. And then actually there's the rocky crust on the very top. So that's kind of what we have going on. So I mentioned we're going to kind of compare the other planets to Earth. So lined up from largest to smallest, and we're going to include Earth's moon down there because it's almost the size of actually Mercury. We have Earth, Venus, and then smaller than Earth and Venus is Mars. Smaller than Mars is Mercury, and then the moon. And kind of at a glance, one of the things that might strike you, if you kind of pick on Mercury, look how big the gray area is. That's the core. That's actually heavy metals, okay, like lots of iron and that sort of thing. Okay, so this is kind of what we have going on in the inner part, this side of the frost line. So each of those terrestrial planets, and actually the moon too, kind of have this, this core, mantle, crust sort of thing going on. And early on when, I was trying to think, had the sun turned on? Probably. The material that was going to make the planet had already kind of gathered together. These planets were still very hot, and so they were molten. And that's important when we talk about planetary differentiation, to kind of think of them as one big fluid, and kind of like salad dressing. Salad dressing, if you shake it up, you have the water layer sinks and the oil layer floats after you stop shaking it up, okay, because of their densities. And the same way, the dense material sank to the centers of all of these planets. So we ended up with very similar structures. You might wonder, well, how do we know kind of the interior of the Earth, and how do we know the interior of other planets? And if you've ever watched the movies Tremors, you know that this idea of basically looking for impacts flowing, traveling through solid, and that's kind of, it's called seismology. So that's kind of how we know what we know. So planetary differentiation, heavy things sink, lighter things rise, while the planet is still what I call ooey gooey. So there are 3 layers to the Earth's interior, but there's actually a 4th layer called the lithosphere. And like the slide says, the lithosphere is the upper part of the mantle, which is solid, okay, and the crunchy crust. Together they make the lithosphere. And the way I think of it is actually the lithosphere then, when we talk about tectonics, like kind of like slabs of Earth floating around on a liquid mantle, it's the lithosphere that is the slab floating around on the liquid mantle. So, and we're going to kind of talk about, or one of the things I want you to know, that rocks, even though we look at a rock and we're like, dude, that rock so cannot change its form. Well, if you, over time and kind of carefully with pressure, kind of deform or conform a rock, you can do that. Okay, but kind of related to that, and doesn't this girl look disappointed? She has silly putty, and if she's careful, she can actually change the shape of the silly putty. But if she kind of abruptly applies that same pressure instead of over time, the silly putty is going to